We have already mapped Mars. We have photographed its valleys, measured its craters, and analyzed its atmosphere. For decades, robots have driven across its surface, sending back images of a world that looks familiar and yet feels completely alien. And still, there is one thing we have never managed to do. No human being has ever set foot on Mars. Not because we cannot see it, not because we do not want to reach it, and not because we fundamentally lack the rockets, but because Mars is difficult for machines. For humans, it is brutal. So the real question is not whether we can reach Mars. It is whether we could survive there. Many people imagine a Mars mission as a longer version of the moon landing. Launch. Fly there, land, explore, come home. But Mars is not the moon. The moon is about 384,000 kilometers from Earth. The Apollo astronauts reached it in just a few days. Mars is something else entirely. Depending on the positions of the planets, it lies tens to hundreds of millions of kilometers away. With today's technology, a one-way trip would take about 6 to 9 months, inside a confined spacecraft, drifting through interplanetary space. And out there is no quick rescue. If something serious happens on the International Space Station, the crew can return to Earth relatively quickly. On a Mars mission, that option does not exist. A fire on board, a medical emergency, a technical failure, a damaged life support system. Everything would have to be solved with whatever is already inside the spacecraft. Spare parts, medicine, water, oxygen, power. No resupply, no evacuation, no rescue team. And while the crew spends months in transit, they are flying through an environment the human body was never built for. On Earth, we are protected by a magnetic field, an atmosphere, an entire planetary shield that silently blocks radiation every day. Between Earth and Mars, that protection disappears. Cosmic radiation strikes the spacecraft from deep space. Solar storms can suddenly throw charged particles across the solar system. Every hit can damage cells, increase cancer risk, or become acutely dangerous during extreme events. So the flight to Mars is not simply a journey, it is the first survival test. And even if the astronauts pass that test, the real problem is waiting at the destination. From a distance, Mars almost looks familiar. It has seasons, mountains, valleys, clouds, dust storms, ancient riverbeds that remind us water may once have flowed there billions of years ago. But that resemblance is a trap. Mars looks like a planet we could walk on. In reality, its surface is a death zone. The atmosphere is about 95% carbon dioxide. Humans cannot breathe it. But that is only the beginning. The air pressure is less than 1% of Earth's. Without a spacesuit, a person would not simply suffocate slowly. The body would be exposed to an environment where oxygen is missing, liquids become unstable, and survival becomes impossible within a very short time. Then comes the cold. The average temperature is about minus 60 degrees Celsius. On winter nights, it can fall to around minus 140 degrees. That kind of cold makes technology brittle, weakens batteries, strains seals, and turns every activity outside a protected habitat into a risk. But even if we could control pressure, oxygen, and temperature, one enemy would still be everywhere: dust. Martian dust is fine, dry, and electrostatic. It sticks to spacesuits, solar panels, vehicles, and airlocks. It works its way into machines, filters, and living modules. It contains perchlorates, chemical compounds that can be toxic to the human body. On Earth, dust would be a cleaning problem. On Mars, it becomes a long-term health and engineering risk. Then there is radiation. Mars does not have a strong global magnetic field. Its atmosphere is too thin to reliably protect humans from cosmic radiation and ultraviolet light. Even after landing, the crew would not truly be safe. Not outside, not for long periods. Mars is not simply a cold desert. It is a world where every basic comfort of Earth would have to be artificially created. Air, heat, pressure, water, protection. Because survival does not only mean shielding yourself from Mars. Survival means having enough resources every single day. Earth and Mars are constantly moving around the sun. They only line up favorably during certain windows. When a crew reaches Mars, they cannot simply turn around. They would have to wait roughly a year until Mars is close enough to Earth again for a return flight to make physical sense. A year on a planet with no breathable air, no open water sources, no food, no hospitals, no industry, and no natural shelters. And during that year, every human becomes a logistics problem. A single astronaut needs roughly 1,100 liters of water per year. Add to that about 365 kilograms of oxygen and around 1 ton of food. For a small crew, that multiplies immediately into several tons of consumables. And every kilogram must either be brought from Earth or produced on Mars. This is where spaceflight becomes mathematics. More water means more mass. More food means more mass. More oxygen systems mean more mass. More mass means larger rockets. Larger rockets mean more fuel. More fuel means even more mass. That is the invisible wall of every human Mars mission. Robots do not need any of this. A rover can drive slowly, freeze, wake up again, collect data for years, and eventually fall silent. A human cannot. A human has to survive every day, drink every day, eat every day, breathe every day, stay protected every day. That is why we can explore Mars with machines, but not yet truly with humans. And even if we solve the survival problem, the most dangerous question of the entire mission remains: how do we get back? The return from Mars is not just the final step. It may be the most dangerous part of the entire mission. Even landing is extremely difficult. The Martian atmosphere is too thin to slow down a heavy spacecraft reliably, but it is still thick enough to create heat, friction, and instability. Mars sits between two worlds, not airless like the Moon, but not thick enough like Earth. That makes every heavy landing a technical balancing act. But after landing, the real risk begins. Because to get home, the crew needs a rocket on Mars. Not a concept, not a plan, a real functioning launch vehicle. With fuel, with life support, with intact systems. That rocket would either have to be sent there in advance, or the fuel would have to be produced directly on Mars, from resources available there, under conditions where no human industry has ever operated. And this is where Mars becomes merciless. If fuel production fails, the crew stays there. If the launch system is damaged, the crew stays there. If a critical part breaks, there is no workshop, no replacement supplier, and no rescue team. On Mars, a failure does not mean delay. A failure can mean there is no way home. We can reach Mars, but we cannot yet land humans there, keep them alive, and bring them safely home. And still, we will try. Not because Mars is friendly, not because it is waiting, not because it is a second Earth, but because every great frontier in human history once looked exactly like this. Too distant, too dangerous, too expensive, too impossible. The Moon was a destination. Mars would be a test of our technology, our medicine, our logistics, and our ability to keep a tiny human world alive inside a deadly one. Maybe one day humans will stand there, under a black sky, on red ground, in a world that would kill them within minutes without machines. And maybe that moment will show what we often forget. Earth is not guaranteed. It is shield, air, water, warmth, and home all at once. Mars is not the next Earth. It is proof of how rare a world like ours truly is.